now that we've learned how to put things into an augmented matrix, we're going to take that augmented matrix and do what are called the elementary row operations. Elementary row operations are we're allowed to interchange any two rows, multiply one row by a non-zero real number, and add any multiple of one row to another row. Now those may look familiar because those are exactly the rules that we had for solving a system of equations by Gaussian elimination. Only thing is we don't have the variables in there now. So we're really doing the same thing. It's just a nice way of organizing it and looking at that information. So what we want to do here is we want to put things into what we call row echelon form. And in row echelon form, we're always going to have this lower triangle, all zeros. Okay, so the directions here say rows consisting entirely of zeros have to be at the bottom, if there are any. Usually there won't be. The first non-zero entry in a row is a 1, it's called the leading 1. And for two successive rows with non-zero entries, the leading one in the higher row is farther to the left. We're just forming that nice triangle of zeros down there. So let's look at how we use the row echelon form with the elementary row operations to solve a system of equations. So first we want to determine if they are in row echelon form. So here we have the first matrix. We see we have a little triangle of zeros here. We have ones along the diagonal here, and they are stepping down as we go, so that would be considered in row echelon form. In the second one, we have a problem with this row of zeros here. The rule said that had to be at the bottom. So if we took that and moved it to the bottom, then we would have row echelon form with that. And the third one, we have the nice triangle of zeros here. We have the ones. We have the row with all the zeros at the bottom. So that would be in row echelon form. So here we have a system of equations represented in this chart. We have hamburgers, French fries, and drinks ordered by 3 different families and the total cost of their items. And so we're going to see how we can figure out, well, what's the cost of the French fries and the drinks and the hamburgers if we have this information. So this is really a 6 times the number of hamburgers plus 5 times the number of French fries plus 5 times the number of drinks equals the total cost for that family. And so if we take that, really we already have the augmented matrix there. So we're just going to rewrite that. 6, 5, 5, 55, 2, 1, 1, 15, and 1, 3, 2, 18. And now we want to take and use those elementary row operations to get what we need. Now I know that I want all ones along this diagonal here. So I'm going to just start off by taking my last row and putting it first to get 1 in this position here. So I have 1, 3, 2, 18. Okay, we're going to take this in kind of small steps here as we go through. You might be able to combine some things as you're actually working with these. So then we have the 6, 5, 5, 55. I'm just going to slide that down 1 and slide the other down 1, also make it 2, 1, 1, 15. So there's our first step, a pretty simple one. So next I'm going to try to get this 6 to be a 0. And I can do that easily by just multiplying the top row by -6 and then adding it to that row. So I'm going to keep the first row, 1, 3, 2, 18. Second row, 1 times -6 plus 6 is going to give me the 0 that I want there. 3 times -6, -18, plus 5, so -13. And -12 for the next spot, plus 5, negative 7. And 6 times 18 would be 60, and 48, 108. So negative 108. So that's going to be negative 53 in that position. So now we've got our 0 there. And let's get the 0 for this position at the same time. So we're going to multiply the top times negative 2 and then add. It's going to get the 0, and going to have a negative 6 plus 1 is negative 5, and then negative 4 plus 1, negative 3, and negative 36 plus 15 would be negative 21. Next, I just really don't like this negative 13 here, so I want to see if I can make that something a little nicer. And so I've decided to take my bottom row and multiply it by negative 3 and add it to that row and replace that row with that. So bottom row, negative 5 times negative 3 gives me a 15, and 15 plus negative 13. So that's going to be a 2 for that position. I like that much better. Negative 3 times negative 3 is 9, and 9 plus the negative 7 is a 2 again. Looking good so far. And the negative 21 times 3, a negative or positive 63. 63 plus negative 53, so that's going to be 10. That row's looking pretty nice now. And in fact, I see that I can get a 1 here by taking that row and just dividing everything by 2. And so let's just leave that row the way it is now and take it and make that a 1 before we do the next step. So I'm just going to leave this as 0, negative 5, negative 3, negative 21. So just changing that middle row, I have them for the top 1, 3, 2, 18. In the middle, dividing by 2, 0, 1, 1, 5. And in the bottom row, 0, negative 5, negative 3, negative 21. So next, we have this position that we want to be a 0. Move this up a little bit. And so I can take the middle row. Again, I have to use the middle row because if I tried to use the top, I would bring some value back into that X column that I don't want there. So I'm going to multiply that row times 5 and then add. So top row staying the same, 1, 3, 2, 1. That's an 18, not a 1 and 8. Middle row, 0, 1, 1, 5. And the bottom row, then we're going to have a 0 still here. And that's going to bring a 0 there. 5 times 1 is 5 plus negative 3. So that's going to be 2. And then 5 times 5 is 25. So that's going to be a 4 there. And one more step then puts us where we want to be. So keeping the top, 1, 3, 2, 18. And keeping the middle, 0, 1, 1, 5. And the bottom row just dividing by 2. So 0, 0, 1, 2. So that now tells me that the 1 here, let's see, that was the drink column, I believe. Let's look back up there. So the drink column, a 1 in the drink column, gives me a 2 in the total cost column. So a drink is $1. $2 make that. So drinks are $2. So back substitute that to find the cost of the hamburgers and the French fries.